Excellent. All right. So just so you guys know, I'm now recording the meeting. Um, that way, I don't know. This will all be going to video, and we'll be sharing that out to the company. So to do a little bit of an introduction, thank you everybody for coming today. This is the end of summer presentations for the summer 2020 internship program. This year, these presentations, the general agenda for today is that I'll do a little bit of introduction, introduce the interns and the projects, and then each intern will be going through and giving a presentation on their summer experience, giving an overview of what they worked on, what some of the interesting challenges were, what they found, what they found interesting, what was not so good, all those good things, get some good feedback. So for the summer 2020 internship program, we had one returning intern, Alex Cohen. She was with us last summer, and so for this summer, the idea was to build out that internship program that we started to lay the foundations of last summer, and the idea being that we want to iterate each summer in order to build this strong program where we can have we can provide very talented students with great technical experience that is relevant to the national security arena, which is where ESS does most of our business. And the idea is that elevate these young people, get them good experience that looks good on a resume, that is also looks good from what the national security needs are of the country. So this summer though, with the best laid plans, we got a little bit interrupted. There was this COVID pandemic that came along, and that changed things a little bit for us. The main change was that ESS went from having an in-person internship where you guys would be sitting in the cube areas with me and we'd be, talking every day, that kind of thing, to a virtual internship. And so what we're seeing right now, this Teams view with, everybody here, this is how we work together this entire summer. And so it's definitely a little bit challenging. And I think we were able to still accomplish our vision when we set out to develop this internship program. But there were definitely some stumbles, things that we could do better. For example, one of the things that's important for an internship, I think, is having sort of insight into the process of how you do your work, because as you're starting out in your career, transitioning from like an academic kind of a way of doing things to a professional way of doing things it's not necessarily an easy transition, and having insight into the process of how you work, you can definitely definitely learn a lot more that way. And so what we had to do instead, just because of the virtualization of the internship program, I guess, is to be more reliant on metrics like basically like what the output of your work is. And so there's pros and cons of each way, but I think overall we did a pretty good job, and it was a great experience. The way we divided it up this year, we have 4 interns. As I said, Alex Cohen joined us again. She was on the cybersecurity team. With her on the cybersecurity team is Shelby Waltman. We also had a blockchain team where we had Eric Stanford and Jenna Buto working together. And so I'm not going to go too much into their projects. I'm going to let them speak about that. But basically, the goals of each project was to deliver something to ESS that that furthers a business objective. And so in the case of the cybersecurity team, securing our networks, our servers, our systems, our applications, that was the objective for that project. And for the blockchain team, it was to deliver a prototype application for something that's a customer need. And for the specifics of that, I'll let each intern get into that. But without further ado, we'll start with the blockchain team. And first up to do his presentation is Eric Stanford from UMBC.
Hey guys, I'm Eric. Let me quickly get my presentation up here. Okay, so I noticed that I was a little bit choppy during the initial introduction, so if I start to lose connection, just let me know and I'll see if I can figure that out. But as stated, I'm Eric Stanford, and welcome to my viewpoint on the Summer 2020 Internship Program here at ESS, which, if I were to sum it up in one sentence, could be boiled down to how I learned to love Stack Overflow. So, a little bit about me. I am a junior at UMBC, currently working toward a Bachelor's of Computer Science and a minor in Biological Sciences, with an expected graduation date around December 2021. Academically, my two big interests are in complex problem solving and in mentoring, which I feel computer science marries those two disciplines in kind of a fun and unique way, because you have to take a really complex problem and break it down into small pieces, and then mentor a machine of sorts to solve that problem over and over again, perfectly each time. And this summer, I was looking for an internship that could let me get a direct hands-on experience in the software development field and the cybersecurity field. And ESS's internship program really stuck out to me because it provided a challenging learning environment where I could grow as a software developer while also balancing the needs to keep myself and my family safe during this whole pandemic with the virtual option. And that really appealed to me, so that's why I went with the program. And on that note, the virtual internship, working with COVID, was a little bit challenging. Making your own work hours in a virtual setting is really great. You know, you can take a break if you need one, but forcing yourself to sit down and actually work those hours is not that awesome sometimes. It kind of takes a little bit of stretch of self-discipline, especially with all the distractions you get working from home. But a lot of things kind of came together to help me sort of keep my focus and keep my productivity high. One of those was the daily check-in meetings, or the Scrum meetings we had. Those were absolutely essential. They sort of let me know where my team was at all times, what tasks were important, which tasks I should be devoting my time to, and sort of where we were on the step to complete our project and all that was going on there. The virtual internship also, by its very nature, encouraged a great sense of self-sufficiency, right? Like, I began to get a lot of confidence in how I could, go and tackle really complex and difficult problems, and just sort of dig deep and rely on myself as a developer and my skills that I'd been taught in school. So with all that said, that virtual internship absolutely met my expectations. The problem was, tough. The technology was cutting edge, and I learned a lot of valuable lessons in the time at virtual internship. The only real thing I'd like to suggest is a little bit more time set for team bonding, but considering the nature of the internship, again, in the situation, I think overall it was handled flawlessly. So now onto the actual meat and potatoes of the presentation, the blockchain prototype we made. First, I want to back up a little bit and look at the big meta question, which is, what if you wanted to transfer data from a secure network to an unsecure network, or an unsecure network to a secure network? Well, your solution would need to do four things pretty well. It would need to be secure so that no one could look at the data as it was becoming secure or going to be unsecure. You would need a tight approval process to make sure that only the only data transferred is data that should be transferred, and keep that regulated. You would want a ledger of the data transferred so that you can see what is moving back and forth, and you want that ledger to be secure and hard to spoof. And you want the solution to be tightly permissioned so that only trusted users can look at the solution and modify it or submit transactions to it. And the big question was, could we use a blockchain to improve the current methods of data transfer and fill those four criteria? And so our goal was to create a prototype application that could be a proof of concept that, yes, a blockchain could be used to transfer data between a secure and an unsecure network. Because a blockchain does all four of those things quite well. They're quite secure. Using a smart contract, you can create a tight approval process to make sure that the data doesn't move anywhere until every party says, yep, it's good to go. By their very nature, they are ledgers of data that are hard to spoof and change without being legitimate. and you can make them tightly permissioned so that only certain users can view the blockchain or submit transactions to them. The prototype architecture is relatively simple. I'll go over it from left to right. On the left, you can see the three parties that we think are going to be interfacing with this application: the transfer requester, the CAO agent, and the data transfer. And they all interact with the front-end application, which is developed in a React framework of JavaScript. This is hosted in an HTTPS server, and simply it is just a dashboard to allow users, depending on what their classification is, to either submit requests, to approve or deny requests, or to make sure those requests are sent through. This then connects to a node server using express.js, and this is where a lot of the processing happens. It does a little bit of a quick error checking, making sure everything is fine, and it will then send all the data packaged from the web application to the IBM blockchain platform through an SDK. This also interfaces with a MongoDB database to keep track of users and know who is using the software and who should have what permissions. And on the blockchain network, that was one of my big contributions to the project. I was the one who actually created the network on the platform. And currently it is comprised of two organizations. An NSA organization, which is sort of a mock-up for the National Security Agency, is the big player on the blockchain network. It's the one that handles the data transfers, transferring the actual data, as well as making sure it's approved and updating old data transfers and all that good stuff. Currently, it only has one peer node in the prototype. This isn't ideal. Usually, you'd want to have multiple peer nodes that can keep each other updated and make sure the ledger is secure and correct. But currently, there is a initial first step into getting those multiple peer nodes, but for now, it relies on only one, and an ordering service organization, which is what the blockchain uses to keep the ledger updated. If you think of it like the NSA organization does all the work, the ordering service is what takes those data transfers and transactions, packages them into blocks, and then puts them on the blockchain. So the NSA does the work, ordering service updates the ledger. There is a smart contract on the blockchain, coded up by Jenna, that currently handles the creation of these new data transfer requests, as well as updating or reading old transfer requests. And there are two users on this network, Bob and Alice, who interface with the application. Bob is currently classified as a CDT requester. He's the one who submits requests, and Alice is the CAO agent. She approves or denies requests as they come in. Some of the things I contributed was the full stack development of the CDT form. It starts out as a simple HTML form in the React framework, and it collects data about the requester and the receiver and the request itself. This data is then transferred to a backend through express.js, where the backend quickly checks, make sure it got all the data is correct in terms of the formatting is proper, and then it makes a call to the blockchain through the SDK framework using Jenna's smart contract to then submit a transaction. I also created a CIO dashboard where it will quickly check if you're Bob or Alice and then direct you to either the CDT dashboard or the CIO dashboard. This is in a very prototype stage. It's not quite fully functioning at the backend isn't up, but the initial groundwork is there, as well as some account management details like logging out and the aforementioned distinguishing between Bob and Alice. And I also wrote a good amount of documentation on the IBM blockchain platform, how the network is set up, and documentation for all the things you see here. So overall, the project was quite successful. We were able to create a successful proof of concept to show that a blockchain can be used to augment this sort of data process with room to expand and add more features as necessary. And I think we showed that a blockchain can be used to transfer data from a secure and unsecure network and record the data transferred. We also were able to create quite a bit of documentation and gather quite a bit of knowledge on the IBM blockchain features and its potential bugs and roadblocks in using the platform and everything that goes along with it, as well as getting a better idea of what the application requires and what some of its potential limitations might be. So, on some reflections as to how the internship went. I learned a lot over my time here at ESS, but I want to highlight a few things that I thought really stuck out to me as important skills. The first one, being a complete surprise to me, was environment onboarding. When I first came in and I was informed of the development environment I would have to set up, it took initially a good bit of work to get that done. But I found that as I found these new tools, it became easier and easier to sort of integrate them on my machine, understand what they all did, why we were using them, and what each application really helped do in our development environment. And that was just a skill that I wasn't even aware was as important as it was. So that was kind of really cool. I also began to sort of think about future team communication, writing documentation and code, not just for the teammates I was currently working with, but for a team that maybe 5-6 months down the line, who I would never personally come into contact with, would need to use to figure out how my stuff worked, how to fix it if it breaks, and hopefully how to keep it from breaking. And the last big thing I learned was about real-world tools and methods and interfacing them with my own code. Because at UMBC, I was taught a lot about how to code well, how to make sure my code was efficient and readable and not kind of sort of sloppy bad code, but not a whole lot about taking other people's code and splicing it into mine so that it all worked flawlessly. And being able to do that here at ESS was really cool, and I learned a lot doing it. And for some highlights, probably the biggest one was the team. Both JD and Jenna were amazing to work with. Both of them were really smart, really good engineers, and they certainly helped to bounce ideas off of or to get a little bit of corrections. And JD in particular was absolutely phenomenal. He was really quick to answer questions, and he answered them in a very clear manner. It was quite nice to be able to work with both of them. And I think one of the biggest things I'll take away from this internship was I built something that was real, something that isn't going to go away when I walk out these doors and the internship is over, like a school project or a little one-time thing that's sitting on my hard drive. It's something that is going to go on to become a actual project in the professional world and have other people working on it. And that was just a really cool feeling to be a part of building something that was permanent like that. There were some challenges, of course. Learning multiple different languages and tools in a quick and timely fashion was a little bit of a struggle for me at first, but I learned that with relentless determination, creative outside-the-box thinking, and an excessive use of Google and Stack Overflow, I could tackle any problem that was put before me, no matter how confusing the documentation was at first glance. Another slight issue was interfacing with other project members, especially being virtual. It was kind of hard initially to keep constant contact. But again, through clear, consistent communication, especially with those morning meetings, I can't stress enough how helpful they were. And thorough documentation, I think we as a team were able to overcome that barrier quite consistently and easily. So some final thoughts and recommendations. Once again, clear, consistent communication was absolutely essential to the internship, especially in its virtual phase. I could have had a little bit more why on the tasking. The detailed what we were doing was amazing and was really easy and clear to follow the steps and the plans we had. But sometimes it was a bit unclear on why we needed a certain program to do a certain thing. So just a little bit more on that would have been nice. A recommendation, something to add, would be joint tasking, particularly during onboarding. I think encouraging interns to work together during the onboarding session and sort of tackle that together as one problem could allow for some rapid team building, get familiar with the other interns on your team, and it might be a nice thing to put in the future. And that while working from the office, because I eventually did come in a couple weeks ago to the office on Tuesdays and Thursdays, while I did find it was easier and more efficient and I could keep my focus better, the virtual internship was still worth it. I learned so much in those few weeks I was virtual. I probably learned more there than I did in my last semester at college, to be honest. Just getting the experience about the problem that was real, the development tools that were used professionally, it was all worth it. And I really cannot thank ESS enough for taking that risk to go virtual and giving me that opportunity, because it was invaluable experience. That said, are there any questions?
Hey, Eric, this is Todd. Question I have is, would you see a workflow tool or an open source product that would help limit the potential risk of a ledger getting, I'll just say, modified in this process?
I'm not sure it would be necessary. A blockchain is really good for keeping a secure ledger. One of the ways it works is if you have multiple peer nodes, which I think currently the plan is to go to 3, each peer node has a copy of that ledger. And when one peer node says, okay, I want to update this ledger, it will quickly communicate with the other 2 peer nodes, which will then do their own check and make sure that is a legitimate change to the ledger. And if they think it's a legitimate change, they'll update their own ledgers and then communicate back to the initial peer node, okay, that's a good change to go. But if they do their own calculations and they see, that ledger is, that change isn't legitimate, that's not correct, the change will stop there and the ledger won't be falsely changed, if that answers your question.
My only thought was inside of another tool, there's other checks and balances of what can actually make a change to a ledger versus if it's all essentially open, it could be spoofed by standing up, 1,000 virtual machines with a different ledger, which would overwhelm the actual ledgers.
You could do a 51. I think that's considered a 51% attack, if I recall my terminology correctly.
Yes.
Okay, I see what you mean. Yeah, I guess I could see that being helpful in that sort of sense. Yeah, I can see where that could.
The 51% attack is really more about it's more about the type of blockchain that Bitcoin uses. I'm trying to remember what they call it.
An open source blockchain?
Well, it's not just open source. It's the blockchain we use is permissioned, right? So it becomes harder to create a 51% attack vector. That's more for a proof of work type of network as opposed to like our proof of, what is ours? Proof of, I can't remember. Maybe proof of authority or something?
Authority.
But it's a different type of blockchain network that is susceptible to that type of attack than what we typically use.
One of the things that we have to help stop that from happening are certificate authorities, which give out keys to trust individuals, and you need one of those keys to even make a request to the blockchain. So that was also a thing I forgot to mention.
Thank you.
All right. Are there any other questions? All right. From the silence, I will say that's a no. Well, thank you so much, Eric. That was excellent.
Thank you.
Yep. So we'll keep it moving. And we'll have Jenna, who's also on the blockchain team, present her portion now.
Yep, let me bring this up.
Yep.
Can everyone see this?
Yep.
Yep.
Okay. Hi, I'm Jenna. Before I get started, I just want to say I hope everyone's doing well and staying safe during these times, and I hope you're ready for your second blockchain presentation. So a little bit about me. I'm an incoming junior at the University of Colorado Boulder, and I'm actually planning on graduating a year early, so in the spring of 2021. So this internship was especially essential for me if I'm trying to find a job as soon as next summer. And I'm majoring in mathematics with a computational track. So even though I'm not majoring in computer science, I'm taking a lot of computer science classes. And my first class was a C++ course last year. And I just found it so interesting that I wanted to do more with computer science and get an internship with computer science. And the reason I was excited to do an internship with ESS is because I've always wanted a government job or a government contractor job from just growing up in this area and hearing so much about them. And then I've also heard a lot about the company through my dad, all good things, of course. So working virtual was challenging, but also pretty convenient for me, at least, because I had a lot going on. I was working 6 hours Monday through Friday, and I was also taking 2 online classes, and I ended up having to get surgery this summer too. So on top of everything and doctor's appointments and exams and everything like that, if it wasn't an online internship where I can stop and go whenever throughout the day, I don't think I would be able to juggle everything. But I thought it worked well having the daily meetings every day, because even though we weren't in person and talking, it was a way to make sure everyone was in track with what they should be doing. Or if you had a problem that you worked on all day yesterday, it was a way to find answers to your problem and be able to explain it. But it was also hard to get errors resolved because, of course, we weren't in person, so you couldn't have the same computers or have the same problems or things like that. So I learned how to do a lot of research and try and figure out my own errors, which is a good life skill. But I would just recommend more contact between workers to get more comfortable with each other, especially towards the beginning when things are online. But towards the end, everything was fine. And then I feel like even though it was a virtual experience, I still was able to get everything out of it that I wanted without actually being in the office. And I was still able to learn a lot. So with the project, I worked with Eric and JD to create a cross-domain blockchain prototype that had a secure login, a web-based dashboard for the request, and used the IBM blockchain platform and had smart contracts. And below is the architecture of what we were using, where it had the data transfer requesters, CAO agents, and the data transfers to input data to the front end, which we used for the React.js. And then the back end was Node.js, which got information from the database, which was a secure database through MongoDB, and then used the smart contracts through the IBM blockchain platform. So the workflow for the user end was on the right. You can see that's a screenshot of what the dashboard looked like, and you could create a new request, and it showed all the requests depending on if they were completed, pending, or denied. And if you click the button to create a new request, it would redirect you to a different web page where you would put all the request information, such as the name and description of the request, as well as the requester and recipient's information. And all the users' information, like I said before, was stored on MongoDB. And then the new request that would get created had a unique request ID created through the smart contract. And the request is verified and stored on the blockchain as a separate transaction. So for the smart contract part, that was my main focus of the project. While Eric did the network, I was doing the smart contract. And we used the IBM blockchain platform extension on Visual Studio. And the functions of the smart contract were to read the request, update the request, delete the request, and create a new request. And for the reading, updating, and deleting functions, you would input the unique request ID as the parameter to have the appropriate actions taken to the right request. Since each one had their own unique ID, you can make sure you're doing it to the right one. And then to create a new request, it would take in, I'm pretty sure, 11 parameters, all which were stated before with creating the new request. And to make sure that the requests were all unique, the creating a new request function actually incremented an ID count to make sure that each ID was unique and that every request had their own ID. And then it also checks to make sure that the request with that ID doesn't already exist. If so, then the request won't go through. So for the IBM network, that's where it stored the user information, connected the user profile to the contract, deployed the smart contract, and put the request on the blockchain. And the two organizations that we had was the NSA and the ordering service. Then there were the certificate authorities that validated the user's identities to ensure the network can be trusted. And on our platform, the two CAs that were able to access and manipulate the blockchain were for the organizations of the NSA and the ordering service. And then there was the wallet that contained all user identities for the blockchain. And the identities in the wallet were used for the CAs to prove their trust. And then for the nodes, that they form the infrastructure of the blockchain, and they're the individual units of blockchain where data is exchanged to update and store on the blockchain. For the workflow of the network, first, the NSA is given a smart contract that executes onto the channel for the ordering service to monitor, and then the CA makes sure that the user is legitimate and recognized in order to continue. And then the NSA has registered users that can assist in tasks, such as generating keys, initiating transactions, and adding new users. And each user had different permissions that they're allowed to do on the blockchain. And then once the transaction is initiated on the channel, the smart contract initiates and performs the transaction. And then finally, the transaction gets packaged into a block by the ordering service. And once the block is full, it gets added to the blockchain, and then the NSA node is updated. So for my intern experience, I learned so many new technologies, like you can see at the bottom. And those included JSON, React.js, Node.js, MongoDB, smart contracts, and these are all things that I've never used before or had experience with. And then I also learned all of the skills from school were just coding with C++, so the internship opened my eyes to all the other different things that were involved other than the small bubble of actually just coding. And so I also got new experience with the web page design, and I had a lot of fun with the front end when I was creating the dashboard because I always wondered how those work. And I really like being neat and organized, and that was essentially exactly what had to be done for the front end, was to make sure that it looked nice and organized. And then the main task I was proud of was the smart contract, because I knew absolutely nothing about smart contracts before this internship started, and I didn't know anything about the Visual Studio blockchain extension either, so I had to figure out both of those, how they worked, how to instantiate, initiate, everything like that, and then figure out how to get it working how I wanted it to. The main challenges was having little knowledge on most things, like I said before, being little new to computers. These were all brand new concepts to me, so I had to do a little more research to try and figure out how things worked or understand the concepts before I can apply them. But everyone has to start somewhere, so I'm really happy that I got to start learning all these things now with an internship before I go to the workforce. And my main challenge of the internship was trying to get the smart contract to increment the ID when it created a new request. For starters, the style of the smart contract with JavaScript was something I had to get comfortable with in the beginning, and then I kept running into errors for initializing the first request ID from not a number to 1. And then once I got that fixed, I ended up having problems with the time where one function was working quicker than the other, so it was causing the wrong number to get outputted. But with help from JD and doing a lot of research, I was able to figure that out. Sorry, the phone's ringing right now. So some thoughts and recommendations for the internship was I felt like I was able to get everything out of the internship that I could have when it comes to work experience, other than actually being physically present in the office. And it helped me get an idea of what it's like applying knowledge from computer science to the workforce, and it prepared me really well. If I was to give a recommendation, I would say that you should give the option, or it'd be helpful to give the option to interns to be able to do part virtual, part in-person internships in the future. Because someone like me who had a lot going on with the classes or with surgery and recovery, I was able to, while working at home, I was able to leave for an hour and go to a doctor's appointment, or leave for an hour and do an exam and then go back to work, and I was still able to get all my hours in. And if I was to give an improvement, I would just say to be able to check up on each other or help each other a little bit more. But of course, that's hard being virtual. And I'm sure that past ESS internships that were in person didn't have any problems with that. That was just one thing with the virtual internship. So all in all, it was a challenging yet fun internship where I felt like I got the right exposure to technologies in the workforce that I would need for graduating next spring. So I just want to say thank you for the experience, and that's all I have for the presentation. Let me know if you have any questions.
Okay, so Randy has a question for the team. So this includes you, Eric. So what should be the next step for this project?
So I think that the next step I would like to complete, if I had more time, is right now we have a good way to submit a new request to the blockchain, but we don't really have a very concrete way of approving or denying the request. So I think the next big step is creating a framework for being able to view requests that are currently on the network and approving or denying them as they come up. I think that's our next big step.
Yeah, I agree. And I also think that maybe a little more cleaning up with just error checking in case, so that things aren't so specific. Because I know, at least with the smart contract, you had to put the parameters in exactly the right way, or you can only update it a certain way. But it would be easier to do error checking with all those and have other ways to be able to do it easier.
Of course, yeah. I think we can get a document up on the Confluence page with the suggestions we can think of as the next steps.
So Jenna, when you were talking about the timing issue, you were talking more of a synchronous versus asynchronous feedback, or are you talking physical time zones?
Oh, no, not the time zones. The problem I was having was I had the get ID and then I had the set ID. And the get ID was working faster than the set ID. So when I would call to get the request ID, that was getting the previous one because it wasn't, it had time issues with the one that was creating the ID. So I had to figure out how to make those get synced up.
Yep. All right. Very good.
Excellent. Any more questions? You can also use chat if you don't have access to a microphone. Awesome. Well, thank you, Jenna. That was excellent presentation. And so that wraps up our blockchain team overview. Thank you, Eric and Jenna. It was awesome working with you guys this summer, and I'm really happy and proud with what we got to accomplish. I think the prototype's really awesome, and it will definitely. Me personally, I'm definitely looking forward to working with it. Continuing to work with that code base. It's a lot of fun to work on that stuff. So, great job. And so now we'll have our cybersecurity team up. The cybersecurity project, again, was to strengthen and secure ESS networks and all that good stuff. And so we'll have Alex Cohen up first. So without further ado, take it away.
Hello, I'm Alex. Okay, so I'm Alex, and I just want to thank everyone again for giving me this really amazing opportunity. And so I'm going to be a sophomore at American University, and I'm expected to graduate in May of 2023. My major is Justice and Law with a concentration in Terrorism and Security Studies, and I have a minor in Information and Systems of Technology. And for many years, I've wanted to be an analyst and work in national security because I love analyzing and I've always been interested in why people make the decisions that they make. For example, like why someone would want to become a terrorist and how they become a terrorist. And for why ESS, I think ESS is an amazing company, and working here has really allowed me to work on my analyst skills. For example, this summer project required me to figure out which IP addresses I needed to do a vulnerability scan on. And ESS has made me want to work in national security even more. And another reason I love working there is because I know that I'm doing work that is actually helpful to the company and that they'll really use it when I'm gone. And it's also just giving me real world knowledge and experience. I also love working at ESS because of how I'm treated. Everyone there is so kind, welcoming, and very helpful. And I'm really glad I got an opportunity to work at ESS again. So working virtually works well because ESS created a well-done program with detailed instructions and modules. I think, like Eric and Jenna said, I really think that the daily scrums really did help because I was able to know what everybody else was doing. And sometimes JD would say, I'm busy, I'm busier today, so if I'm not around, I'll answer your questions later. So for me, that was really helpful because that way I knew if he was going to be busy at a certain time or if Shelby was going to be busy at a certain time. I thought it was going to be harder than it actually was because I wasn't sure how it would work since I'd have to do more on my own. But JD was really helpful, and he did a really good job of coordinating with the interns and making sure that we had everything we needed in order to succeed. And he would always make sure he would answer our questions and help us in a timely manner. Sometimes it would take me longer to complete something because something worked differently on my computer than it would at the office computer, but eventually I figured it out. And overall, I think the internship working virtually was really helpful, and I was still able to learn useful skills and be a part of a professional atmosphere. And I'm glad towards the end I was able to come into the office on Tuesdays and Thursdays. So overall, our project was to find the vulnerabilities in the system and figure out if there were any issues. And I got to work with Shelby. And pretty much what we did is we did a bunch of different things. We used a bunch of different things to find the vulnerabilities, and we made a detailed report, and JD has that, and he'll use that to figure out what he needs to do. So first, I used a lot of different videos that JD gave us on ESS University. There was some Security Plus, CompTIA, and ethical hacking. I really like these videos because they really helped me to understand how the computer system worked. I learned a lot of different topics because each course had different content and they had hours worth of content. I learned how Kali Linux works and how to ethically hack inside Kali. These videos also taught me how to use analysis and penetration tools like Wireshark and Mmap. I also learned how to conduct a vulnerability scan. And these videos will be also really helpful for my career because they taught me the importance of keeping my technology safe and how to analyze better. And then the second thing I did was these virtual labs within ESS University. So these labs really allowed me to see how computer systems work because I either had to fix a vulnerability or an issue or perform a certain kind of attack or hijack something. These labs really taught me how easy it is to perform a certain attack on computers. And I really liked the labs because they really did a good job of explaining the step-by-steps, like the steps of what to do in order to complete the attack or fix the issue. And it really helped me to protect so that I know how to protect my computers or any computer better and just use useful tools. An example of a lab I really liked, it was called the Vulnerability Scanner MBSA because it allowed me to see the risks and vulnerabilities that the lab had along with how to fix them. And having these detailed step-by-step instructions demonstrated how easy it is to gain someone's information and the importance of keeping computers safe and well protected. And the labs also made me realize that you really need to be careful about what you put on your social media accounts, because if someone's trying to figure out your credentials, they may use your social media account to try and guess your username or password. And then the next thing we did was capture the flags. So I loved working on the capture the flags because it was a lot of trial and error, and while sometimes it was frustrating, it was challenging and allowed me to understand how the computers work and how easy it is for hackers to access someone else's information. While some were easier than others, I still enjoyed them. Also, it was helpful because I learned different technical skills. For example, the cryptography, website, and forensic challenges were ones that I completed the most. So the cryptography ones would be like decoding a certain sentence or figuring out a cipher that like got shifted. So that was like really fun because I had never really done something like that before. And then, so we performed a fake phishing attack. So JD set up a test account on the ESS network so that Shelby and I were able to play around on the system without messing up our accounts. So an example of what we did on the test account was we sent a phishing email to the test account and we didn't do anything malicious, and the hyperlink wasn't malicious, but the email still looks real. So theoretically someone might click it. And on the right is an example of the phishing attack that we created. And then we did a lot of vulnerability scans, and the first vulnerability scanner I used was Nessus, and that was extremely helpful because I used the IP addresses that I got from Nmap and chose which ones to perform an advanced scan on, which searches for the risks and vulnerabilities on those IP addresses. So I scanned 13, and there were 3 that produced critical or high issues. Out of the 13, the totals were 3 critical issues, 5 high issues, 76 medium issues, and 13 low issues. And while the scans showed those as the total, that's not actually the total because a lot of the issues will overlap because more than one IP address can have the same issue. And I generated the vulnerability reports for JD, and Nessus did a really good job of like making sure they outline what the issue is, how to fix it, and like how to prevent it for the future. So I think this was extremely helpful because now JD knows what he needs to fix and how he can fix them in order to protect the ESS network and make it less vulnerable. I think the intern experience worked out really well, and it's going to really help me later in life because I learned a lot about how to keep my computer systems safe and how to protect my information and make it more secure. These skills will also be helpful for me in college because my minor is information systems and technology. So I think learning how the computer system works will really be helpful for me in my classes. Also, just learning about how to search for hidden documents within files or find hidden messages within pictures, or using online cipher decoders because I had to use those a lot in the CTFs. I'd say the challenges were that sometimes I would download the wrong version of something or not know how to do something. So I would a lot of times use Google, and I would just follow along with the video so that I could get done what I need to get done. For the CTFs, I used a lot of videos to figure out what I had to do because sometimes I knew what I had to do, but I didn't know the exact steps to get there. And when doing those CTFs, knowing the exact steps is really important because sometimes you wouldn't get the flag if you just missed one step. JD was really helpful when I had a roadblock because he would make sure to like walk me through the process. And a lot of times he would just stay on the phone with me to make sure I actually got my roadblock and like got past it and did it correctly. And Shelby was also really helpful in solving my roadblocks because a lot of times we would work together. A lot of days we would just FaceTime for a long time and figure out why something wasn't working for one of us, and that was really helpful. My thoughts and recommendations. I thought it was a really great opportunity. I'm really thankful I got to work here again. And I think for like recommendations, I would say just like if you, like what Jenna said, maybe have the option to go virtual in the future because sometimes like I know for me, like I love working in the office, and working in the office was great for me. But I think like for Jenna's case, sometimes like someone else might have something else going on, so that could be helpful. And I think definitely if you guys had to go virtual again, I think you did a really good job of like quickly switching over to virtual. And I think the daily scrums and then the retrospective meetings every 2 weeks were really helpful, because for me, that really gave me an outline of what I needed to complete within the next 2 weeks, and then to see where my goals were for the following weeks. And for me, that's important because I like knowing what I have to get done within a certain period of time. So then because that way I felt like I wasn't behind on what I was completing. And that's it. Any questions?
Yes, it's Bill. Did you guys identify the critical issues that need to be fixed and when or how they are supposed to be fixed? Is that documented?
Yeah, so JD has like a full report of them, and he knows how to fix them. But one of them was, I don't really know what JD knows more about them than I do, but there are certain ones. There was one that's like a Windows issue that JD knew about, but he hadn't fixed it yet. And then there's some about the servers, and then there's like some stuff that's like something is unsupported in the Windows operating system that I would just have to be fixed. But he has like, there's like, and that's just provided a whole report, and it's like 900 pages. So he has like all of the answers to everything and how to fix, like he can fix all the issues that he thinks is necessary. But
so that might be something good for a follow-on, JD, is a graded report, I guess, of all of those vulnerabilities. Because a lot of times obviously you want to fix the critical and the highs. Sometimes you might find things in there that even a medium is more important to fix first than maybe the high is. Right, so it'd be good to have that type of report as well. And of course, JD, you fixed them all already, right?
Not yet. That's still in progress. But for the critical ones, I have addressed those. For example, one of the critical ones was the DNS server issue that the CVE came out for Windows Server, where potentially an upstream DNS server could execute malicious code on on the Windows DNS server and take control of our thing. So yeah, so I addressed that one pretty rapidly once I was aware of it. But as far as getting deep into all of the other ones, that has not yet happened yet. But that is definitely on my to-do list, my plan for the future.
Another interesting thing that a follow-on team could do is look at how to automate generating the report. So you would get a weekly email or something like that of the problems.
For sure, that's definitely useful.
Is this something we can bundle and potentially sell as a service or a package?
So yeah.
Well, I mean, there are other people that already do that.
Yeah, I mean, essentially, I tried to replicate kind of what was already out there with what other cybersecurity companies do, where they do like they come in and they'll do a vulnerability scan or a pen test or whatever, that kind of stuff. So the process was pretty similar, and it is definitely something that if we want to provide that service, we have the framework for it now.
Okay, good.
We do have a question from Randy. I don't think that. I guess I kind of maybe already answered it. But what was the biggest vulnerability you found, and what was the risk?
I think it would be what JD was talking about, probably the Microsoft DNS server, because like what he was saying before, you can take over someone else's, right, JD? Like you can.
Yeah, it would take over the server where our DNS server is running, which would be a very important server.
Yeah, and so I remember like when I found that, I was like, because this was one of the first critical issues I found, and I asked JD, I was like, this doesn't look good, JD. So then he was like explaining it to me. I was like, yeah, that does not sound very good. So I think that was probably the worst ones. And then when JD was looking at the other two critical ones, he definitely said like the Microsoft DNS one was probably the one that was the worst and that needed to be fixed, which he did fix. So that's good.
All right. Any more questions? Excellent. Well, thank you so much, Alex.
Thank you.
Great presentation. Yep.
Thank you.
And for our final presentation of the day, thank you for waiting so patiently, Shelby. Shelby Waltman from UMD, you are now up. Take it away.
Okay. Hi, I'm Shelby, and give me one sec. So I'm a University of Maryland College Park student, and my major is information science with a specialization in cybersecurity. And I graduate fall 2020, and I've always wanted to intern with a contractor or a government agency for a while. And I've always I've been interested in stuff like penetration testing or being like a cybersecurity analyst. And I originally was supposed to intern somewhere else, and they weren't the most professional and didn't actually end up following through with me. So one day I was looking around on LinkedIn and I found ESS and applied. So I was really excited to become an intern here, and I appreciate that I was given a chance to intern here, especially with the whole COVID situation going on. And I definitely don't regret choosing ESS. So as far as working virtually, I worked a lot with Alex, and we would FaceTime almost every day of the week, and we would work together on whatever we had to do that day, whether it was capture the flag or hack the box or the vulnerability scans. And so we tried our best to split the workload up. And we would talk to JD over Teams, and we would consult with him on any issues we had. And he was always really helpful and would get back to us with any questions we had, and was just always available. And I think what worked the most was being able to always have help and have assistance, like if we had an issue with stuff. And it was also really nice to be able to work together, to have somebody else to work with and do like the daily Scrum meetings and stuff like that. And it helped add like a lot of structure to the internship and made me feel like I was actually doing like being in person kind of on a schedule. And it helped add responsibility because we would talk about what we'd be doing each day and what we needed to get done. And I feel that it wasn't overly complicated for the most part to complete the work virtually because I feel that we communicated a lot and kind of discussed all the things we would be working on together. And I think due to the fact that a lot of the stuff that we do or we're working on involved computers by default, it wasn't the hardest transition to make or the biggest difference it could be. The virtual internship definitely met my expectations because I expected it to be something that I had never encountered before, experienced, because I've never worked at a contractor or intern online either, or worked remotely, other than maybe like doing classes online. So that's the closest I got to that. And my overall assessment of virtual work is fairly positive. I know for a fact that I would much rather work in person, just because I think that doing hands-on stuff is definitely better for me personally when it comes to learning stuff. And working virtually definitely was a good thing to have, though, especially with everything going on now. And I can't think of any other recommendations other than the fact that I think encouraging people to work together and really kind of collaborating to get stuff done is like a really important thing to encourage people to do. So Alex was on my team. Alex and I worked on ethical hacking and vulnerability testing. We used tools like Kali, vulnerability scanners. We did some simulated phishing attacks that she showed in her presentation. I also have some of those that I'll show in mine. And we used Wireshark and more. So we both would work together and we would brainstorm different ideas, techniques we could use for within like the first few weeks. And then we kind of created a plan of action and discussed amongst ourselves like what we'd be doing. So the first tool we kind of experimented with and learned stuff about was Kali Linux. And we set up a virtual machine environment for that. And I set mine up with a Raspberry Pi that I own because I've worked with Kali a little bit in the past. So I have one of those. And we learned a lot of stuff about stuff like password cracking, like brute force attacks and other stuff like that. And I'll talk more about the techniques and different things we used in the next few slides. So the objective of the project, we were supposed to find vulnerabilities within ESS using a variety of tools. We needed to make sure we would do this in an ethical manner, being mindful of what we did, not doing anything that would breach privacy or anything like that that was unethical. And also to gain real-world hands-on experience in the field of ethical hacking. And I personally feel that the objective can definitely be seen differently based on who you're asking, but the general objective was to find vulnerabilities. Personally, like the objective for me was, and I'm sure Alex would say the same, is to gain real-world or real-life hands-on experience in the field of ethical hacking or penetration testing, that kind of stuff. That was something I definitely looked forward to, was to be able to say that I've experienced this and actually worked with this kind of stuff, because I always am wanting to learn more. So from a general perspective, the main goal was to do what we were assigned to, and that was testing for vulnerabilities and stuff like that. So what I contributed, my contributions consisted of working on the red team report with Alex, and we both documented our findings. Each day we worked together and we documented just about everything that we did, saying if the tool we used worked, or if the method we used worked or didn't work, if it was successful or if it was a fail. We also described as far as describing what worked or didn't work, we would add in a screenshot and show an example of what we had done, or discuss stuff like Wireshark, like what we did with Wireshark. And after this, in the next slide, I'll have a slide showing some of the examples of the things that we accomplished. And as far as prior knowledge, I had a little bit of prior experience from a separate internship, working with different types of technologies and things like simulated phishing attacks. And I've learned a little bit of Kali on my own, so I knew a little bit of that stuff going into this. And one thing that helped a lot too was studying for Security Plus while working on this. I actually got mine yesterday. I passed yesterday. And it helped me understand a lot of the things we were doing. And I could explain certain things and concepts to Alex that we may have been told to work on. And if I had heard of it before, then I would explain it to her and we would kind of work through it together. And we learned a lot about hacking techniques early on in the planning. Like I said, like doing capture the flag activities and using Kali. The coolest hacking tool that we learned about and used a little bit was John the Ripper. It was a cool tool that showed how to crack passwords and stuff like that. And any roadblocks we encountered, we talked over, and we were able to help each other with those or ask JD for help on those. And here is an example. This is an example of one of the phishing emails we created. So this was just a pretty basic like template that we created. I have a little bit of a background in graphic design, so I created this. I used the tool I had on my computer, and at first we were just trying to see if we could make something that looked realistic. So we just used Netflix as an example, even though we weren't really going to do anything related to sending like an actual like Netflix email. We just wanted to see if we could kind of use it easy to start the idea. And I did some research on phishing emails to kind of see how we could make it look real. And we ended up sending this to a faked Pwn user account that we used on the remote desktop. We originally tried using different programs for simulated phishing attacks, and they didn't work as best as we wanted them to work. Like we felt that they could have worked a little bit better, but that was a roadblock with that. Like we kind of ran into some issues with downloading certain things, and they could have been a lot more easier to use. So we ended up kind of crafting these ourselves. So this is our final product of the phishing email. Alex showed this one already. So the link for this that was embedded, also it works, but it just redirects you to a website that isn't malicious. So we were just trying to create an email that looks like it could be believable enough to where somebody might click on it and mistakenly go to a website that they shouldn't be going on or being phished by someone. And you can see the information above. This is a little piece of information from the red team report that we did. It explains what we were doing, the techniques and procedures, and if it was successful, a fail, or partial. This one was a success, and we feel that we did a pretty good job on it, so we chose to put this one in the presentation. And this is a example of one of the vulnerability scans that we did. We used a tool called Rapid7, and we used it to run a test on the system, and it came back to us with a few different or several different vulnerabilities. There was a good amount of information it gave us. The one that Alex discussed definitely gave us more information, but this one had a bunch of different stuff, and we felt that it was a pretty good one, and it was a success. So the internship, it was all around really good. I felt I learned a lot, especially being able to experience working on a team within the field that I would really love to go into. I learned to work online and remotely, which is something I had never done before, and also never worked with these kind of tools in a real life environment to get experience with this kind of stuff. And in the end, I really appreciate being able to work here or intern here, because I felt that I did learn a lot of stuff that I hadn't used before, like I said, and get a more hands-on experience. And for the most part, there weren't too many incredibly crucial challenges, other than the fact that there were some things that we downloaded, like I mentioned before, that weren't working. And being new to some of the tools that we were using that I hadn't used before, and Hack the Box, that was something that was like a capture the flag type of thing that we were both new to. Some of it had some really advanced, like higher level hacking stuff that we struggled with a little bit. And I think that was probably like our main challenge. And overall, for the most part, I would say that the only other major issue was the fact that I had a lot of stuff going on. Like I had 3 classes, and I was also studying for Security Plus, and that made it definitely made me have a lot going on at once. But for the most part, no other challenges. And any questions?
Sure. So we have one question from Randy. So he was wondering, with the phishing test, how many people clicked on it?
So what we did was we actually sent it. So we actually sent the phishing email to a I guess fake like email that we had on our remote desktop. So we didn't actually like deploy it and send it out to people, because that was just, I guess we didn't really think, I guess, to do that, because we were worried about like sending it and just like the whole like ethical thing behind it. So we kind of just focused more on creating it and sending it and seeing if it would be received, looking and look pretty like authentic. Like we wanted to see if we could send it through an email and if it would pretty much look how we wanted it to look.
I think that would be a great additional test to do, is to actually try to create one and send it to the ESS hall or whatever it is to see how many you could fool.
Yeah.
What should pop up should be, you should make them take a test, and they can't go anywhere else on the computer until they pass the test.
That's a good idea. Yeah.
Yeah, that would be that would be fun. Yeah, if we have more time this summer, definitely something we would look into. All right. Congratulations again on getting your Security Plus.
Thanks. Thank you, everyone.
Great. If any more questions before we close out here?
You know, it's me, Paul. I'm very impressed with all 4 interns. Very, very impressed. Did a great job. And JD did a phenomenal job also. So I'm impressed with you guys. So, you know, so keep in touch with us. Maybe we can keep some kind of communication with career with ESS or something of that nature, especially in our world that you all, you know, exhibited or stated some kind of interest. Maybe if there's some openings, Todd, the guy right up there, Todd, if you're looking at him, can help you get cleared in our area. And we're trying to get Alex right now cleared, you know, because she interned last year with us. So, you know, let's just see what the path brings. But again, thanks for being part of this. And, you know, like I said, I'm very impressed with you guys. You know, good luck in your travels. But please keep in touch with JD and Bill. So maybe there's something for you here at ESS when you graduate or thereof. So again, thanks.
Yeah, great job, everybody.
Yep. Thank you, everybody. Yeah, this was a great summer. I'm really glad I've had the opportunity to work with everyone. It was a lot of fun for me. I also learned a lot. So I mean, I definitely had a great time. So I'm looking forward to you know, next summer, see who comes back, all that good stuff. But yeah, if there's any other last words, and if not, we'll go ahead and we'll close out here.
Yeah. All right. Well, take care, everyone. Enjoy the rest of your summer.
All right. Thank you so much, everyone.